On May 6, 1942, when the fortress island of Corregidor finally surrendered to Japanese forces, thousands of American M1 Garand rifles fell into enemy hands. They were scattered across tunnels, bunkers, beaches, and blown-out defensive positions, some of them still warm from the last American soldiers who had held them only minutes earlier. Many rifles were dropped where men had fallen. Others were stacked in desperate surrender. All of them were shipped quickly to Manila Bay, where Japanese naval ordnance teams had been waiting, not for the island to fall, but for the rifles that would come with it. These officers were specialists, men who had spent their entire careers evaluating weapons from around the world. They had studied Mausers from Germany, Springfields from America, and Mosin-Nagants captured from the Soviets. They believed they understood what a rifle could be and what a rifle could do. But the M1 Garand looked different, heavier, denser. The weight distribution felt strange in the hands, almost unbalanced to someone who had trained exclusively with Arisaka rifles. The Japanese Type 38 was slim, elegant, familiar, the way a rifle should feel. The M1 was thick through the stock, its receiver blocky, its action oddly complex. And yet the mechanics intrigued them. The bolt moved in ways they did not expect. The operating rod traveled along a strange curved path. Intelligence reports had claimed that the American rifle was semi-automatic, that it held 8 rounds, that it could fire with unnerving speed. But reports were just ink on paper. The Japanese needed to witness the rifle themselves. When engineers finally tested the captured rifles, what they saw sent a quiet shock through Naval Command and triggered one of the most desperate and secretive engineering efforts ever attempted in Imperial Japan. The Japanese 14th Army had expected the defenders on Bataan and Corregidor to break quickly. They expected tropical disease, starvation, and low morale to collapse the American-Filipino lines within weeks. Instead, they faced 4 months of brutal resistance. Many officers wondered why the Americans and their Filipino scouts had been so hard to dislodge. When the engineers saw the rifles up close, they realized the defenders had possessed something far more dangerous than previously understood. The first time Japanese troops encountered the M1 Garand in large numbers was January 10, 1942, when they assaulted American positions on the Bataan Peninsula. The Philippine Scouts, elite Filipino troops led by American officers, held the line. They were disciplined, experienced, and armed with new rifles the Japanese had never seen before. The attack began with artillery. Then infantry advanced in waves, just as they had done successfully in China. But this time, something was wrong. The volume of fire coming from the American trenches sounded impossible. Japanese company commanders thought they were charging into multiple machine guns. The noise was continuous, an unbroken storm of individual shots, precise and rapid. Men fell before they could close the distance. The scouts weren't firing in the rhythmic crack-pause-crack pattern of bolt-action rifles. Their fire came as a seamless roar. One Japanese unit was shredded in minutes without ever reaching grenade range. After the battle, Japanese officers reported that American positions must have been reinforced with large numbers of automatic weapons. To them, this was the only explanation. They were wrong. The Philippine Scouts had no additional machine guns. They simply had M1 Garands, and soldiers who knew how to use them. Lieutenant Colonel Philip Fry, commanding the 3rd Battalion of the 57th Infantry Regiment, wrote afterward that the killing was beyond his ability to describe. His soldiers maintained a rate of fire that seemed impossible for infantrymen with rifles. And what those Japanese attackers could not have known was that each scout could fire 40 to 50 aimed rounds per minute. The average Japanese rifleman, armed with a Type 38 or Type 99, could deliver maybe 15 accurate shots per minute. A talented marksman might push toward 20, but only briefly. The mathematics were devastating. One American with an M1 could match the firepower of 3 Japanese infantrymen. A single U.S. squad could match a Japanese platoon. Most importantly, M1 users never had to take their eyes off the target to work a bolt. They just kept firing. The Arisaka rifles were not bad weapons. Far from it. The Type 38 was a beautifully made 6.5mm bolt-action rifle, accurate and durable. The Type 99, firing a heavier 7.7mm cartridge, was modernized and lighter. But they were bolt-actions built for a world rapidly leaving bolt-actions behind. Time had moved, and the Americans had moved with it. The rifle that changed everything had been designed by John Cantius Garand, a quiet, meticulous Canadian-born engineer working at Springfield Armory. He began refining semi-automatic rifle designs in the 1920s, long before the U.S. Army fully understood the value of such weapons. The M1 was officially adopted in 1936. By 1941, the United States had already produced about 100,000 of them, and had ramped up production to unprecedented levels. Springfield Armory and Winchester both built them. Tolerances were designed for mass production. Parts were interchangeable. The rifle was engineered for factories, not artisans. America built over 4 million of them during the war. Japan never stood a chance of matching that output. But numbers alone were not what shocked the Japanese engineers outside Manila. It was the way the M1 fired. Their first test used 6 rifles in good condition and 200 rounds of captured .30-06 ammunition. Engineers loaded the first rifle with a distinctive 8-round N-block clip, the metallic snap echoing across the ruined airfield. They began firing. The rifle bucked, the action cycled, brass casings flew, and the shooter never paused to work a bolt. 8 rounds in 7 seconds. All accurate. The empty clip pinged out with that unmistakable note Americans would later celebrate as iconic. Reload in under 3 seconds. 8 more shots. 7 seconds. This was not merely an improvement. This was a new category of weapon. When they fired the Type 99 for comparison, 5 rounds in roughly 20 seconds, the disadvantage became painfully clear. The engineers were experts. They understood gas systems, cycling pressure, extraction timing. But understanding theory was nothing compared to watching a rifle triple your infantry's firepower simply by existing. Their report that night was painfully blunt. One American rifleman with an M1 Garand equaled 3 to 4 Japanese riflemen with Arisakas. Infantry doctrine, unchanged for decades, was suddenly obsolete. The Army ignored the findings. Pride, bureaucracy, and tradition blinded them. The Navy, after the disaster at Midway, could no longer afford such blindness. In late 1943, the Navy began a bold, secret project at the Yokosuka Naval Arsenal. Reverse engineer the American rifle and build a Japanese version. What followed was a race against time, and the clock was brutally unforgiving. The first challenge was ammunition. The M1 used .30-06 cartridges. Longer, different in diameter, different in taper. Japanese ammunition simply didn't fit the M1's N-block clip system. The engineers tried to modify the rifle to feed 7.7mm Arisaka rounds. It worked, sometimes, but unreliability in a combat rifle is death. Clips jammed. Rounds misaligned. Tolerances refused to cooperate. So the Japanese made a fateful decision: abandon the American clip system entirely. They replaced it with a 10-round internal magazine loaded from the top via 2 Arisaka-style stripper clips. It simplified production but required redesigning much of the rifle's internals. The trigger group changed. The follower changed. The bolt geometry shifted. The gas system needed recalculating to account for different cartridge pressures. And all of this required steels Japan no longer had enough of. Heat treatment furnaces were overworked. Alloy shortages were constant. Bombing raids disrupted prototype machining. Still, by March 1944, they produced a working prototype, the Type 4 rifle. It looked like an M1 at a distance, but its magazine bulged slightly. Its sights were Japanese style. Its internal feeding system was new. It was the closest Japan had ever come to matching American firepower. But prototypes don't win wars. Production tooling would take months. Factories would need reconfiguration. Skilled machinists were already working 16-hour days. And America kept advancing. Reports from Guadalcanal, then New Georgia, then Bougainville all said the same thing. Japanese infantry simply could not close the distance. Banzai charges that once shattered Chinese lines were now suicidal. At night, infiltration units were cut down by sudden bursts of fire from rifles that behaved like automatic weapons. The M1 had changed the rhythm of battle itself. The Type 4 rifle was Japan's answer, but time was the enemy. By spring 1944, the team finally had 10 working rifles. They tested them repeatedly. Reliability hovered near 90%. Good for a prototype, not good enough for a battlefield where mud, rain, and chaos would drag that number far lower. They refined springs. They altered extractor geometry. They reinforced operating rods. But each improvement added machining time Japan no longer had. Still, the engineers kept pushing. By late 1944, just as American bombers devastated Japanese industry and U.S. Marines clawed their way across the Pacific, Japan finally began preparing for limited production. But the war had moved too quickly. Materials ran out. Factories burned. Power outages became constant. Skilled machinists were drafted into infantry units. And so the Type 4 rifle remained what it had always been, a desperate hope, too little and far too late. Most historians believe perhaps 50 rifles were ever completed. Some say fewer. None ever reached frontline units. And yet, those who held the prototypes understood one sobering truth. Had Japan fielded the rifle years earlier, had their industry been capable of producing even a fraction of what America produced, the infantry battles of the Pacific might have looked very different. Instead, the story ends with a quiet irony. The Japanese engineers who worked tirelessly to copy the Garand were among the first to admit, privately, that what they truly admired was not the rifle itself but the industrial miracle behind it. America had not just built a weapon. It had built the machines that built the rifle, then built more machines to build those machines, until the rifles rolled out by the millions. Japan tried to copy the steel, the shape, the mechanics, but the real secret of the M1 Garand was the factory behind it. And no arsenal in wartime Japan could replicate that. In the end, the M1 Garand did not just outshoot the Arisaka. It outproduced it. And that difference shaped the fate of the Pacific War more than any single bullet ever fired.